Welcome to this 7th lecture in the series of lectures on textile printing. From this lecture onwards, we will be talking about the actual printing techniques. Before this, we have covered how the fabric needs to be prepared and we have discussed the machines that are involved in it. We have looked at printing in general as well and the fabric characteristics that affect printing. So let's look at the learning outcomes for this video. This is all about the different textile printing methods that have evolved over the past few centuries. If you look at printing from a historical perspective, you will find many different methods. However, we are going to focus only on those methods that are significant or that have been significant in past for producing printed textile fabrics on a larger scale or on a commercial scale. And these methods include block printing, roller printing, screen printing, and the most modern technique of printing on textiles known as inkjet printing or digital printing. The idea is that when we look at these printing methods, we should be able to compare these methods against each other, and we should be able to see how one method is better than the other in terms of quality, in terms of number of colors that we can print, or in terms of cost and efficiency. The first method of textile printing that we will study is widely known as block printing.
Block printing is arguably the oldest method of printing on textiles. The procedure has multiple steps in it, of course. The first thing that is done is that the design that needs to be printed is carved on wooden or metallic blocks. Mostly, wooden blocks are used. So as you can see in the image here, with the help of specific tools, the design will be carved onto the surface of a piece of wood. And in this image here, the white areas that you see are the design areas, as these will come in contact with the fabric, while the dark brown areas that you see are recessed areas, and you can refer to these as the non-design areas. So the impression of only the white raised areas will be produced on the fabric. Once this is done, the printing ink is applied onto the block. The printer here needs to be very careful because we do not want a lot of ink on the block, as it might fill the non-design areas as well, and therefore printing ink in the non-design areas will also be applied onto the fabric. So a controlled quantity of ink is applied on the block. And then in the next step, this block on which we have applied the ink is sort of stamped onto the fabric. I'm sure you all have seen a stamp, so it's a similar action. The block with the ink is pressed onto the fabric, and so the ink is transferred onto the fabric. If you look at the cross section of a block, you probably have already realized that the ink is applied on the raised areas in the block, and those are what we refer to as the design areas. And as I've mentioned, the quantity of ink that we want to apply on the block is just enough to fill these or to cover these raised areas of the block. We do not want any ink to go in these recessed areas because these are the non-design areas. So in this process of block printing, the print quality depends on, of course, the quality of carving on the blocks. If the design is not carved properly, then of course it will not be printed properly. But then as far as the correct carving is concerned, there is another aspect to it. The fineness of the design is also determined by the fineness of the carving on the blocks. So actually, it's the skill of the person who actually carves these blocks, that how fine designs that he or she can produce on a piece of wood. Then of course, the print quality depends significantly on the skill of the printer. From this point, what I mean to say is that when this block is pressed onto a fabric, the force with which this block is pressed will determine the uh, the sharpness or the brightness of the color as well. So you can imagine that if a block is pressed too much on the fabric, then it could cause sort of smudging of the print. So the print will spread slightly from its actual desired boundaries. And then that's one aspect. These prints, as you can see in the image here, these can be, I'm referring to this image. Block printed fabrics can have designs which cover the entire surface of the fabric. So the printer has to repeat this step of stamping the block over the entire width and length of the fabric. Now, if the pressure with which the printer is pressing the block changes in every cycle or in every subsequent step, then of course the appearance will also be uneven. So the skill of printer refers to how accurately the printer can position the block on the fabric, and then secondly, how uniformly the block is pressed every time. So these are two aspects related to the skill of the printer. A very important feature to note about block printing is that there is no theoretical limitation on the number of colors that can be printed, because all that needs to be done is to produce multiple blocks, and each block will be used to print one color. So it's up to the printer that, let's say if in a design there are 20 colors, they can produce 20 blocks. So there is no theoretical limitation. This is a very important point, because you will see that that in most of the automated printing processes, there is a certain limitation as far as the number of colors are concerned. Now you might be thinking that if we are printing, let's say 25 or 30 colors in a block printing process, then that will be a very complicated print. But what I mean to say is that theoretically it is possible. So coming back to this point regarding the block itself, of course, depending upon the skill of the engraver, very fine designs can be carved on wood. So in this image here, you can see that it's an incredibly fine design on a piece of wood. So in summary, the quality of a block printing process almost entirely depends on the quality of blocks, which in turn depends on the quality of engraving that is done. So that's somebody's skill. And then as far as the print quality is concerned, the accurate positioning of the block and the force with which block is pressed is also uh, actually depending on the skill of the printer. Now it's evident that as such, there is no huge investment required to start a block printing setup, because there are no machines involved. There are some pieces of wood. Of course, the cost of wood can be a factor to consider, but in comparison to automated printing machines, there is virtually no capital investment. However, it's obvious that the production rate is very low. Therefore, block printing is no longer a commercially significant process of printing of textiles. It's more like art these days. Another important feature of block printing is that almost any type of textile substrate can be printed. And this means that you can print a very heavy GSM fabric, a very thick fabric, and then you can print some very low GSM light quality fabrics as well using block printing. And that is because we are controlling the printing process by means of a printer who is applying force on the block to transfer the color from the block to the fabric. And depending on the type of fabric that is being printed, the printer can adjust the force he or she is exerting on the block. And that is why it is possible to print any substrate. You will see in the next method of printing, which is roller printing, that there are limitations of utilizing that process for printing light quality of fabrics. Perhaps some of you are already thinking about Ajrak, which is of course a very good example of the block printing process. So let's have a look at a short video to further understand this process and its characteristics. So that's a very well-known design of Ajrak, and you can see that the printer has to spread the fabric manually, and then you can see the block in his hand. It's a wooden block. The positioning of the block is critical, and then the force that he applied is also very significant because that will determine the shade or the quantity of ink that is applied on the fabric. These are the wooden blocks mentioned as printing stamps here, and you can see that it's a very intricate pattern being printed. So once again, notice that how carefully this printer is first applying ink on the block. So it's a very controlled quantity of ink, and then he's carefully positioning the block. Right. So if you go to interior scene, you can find this ajrak in many different styles and colors. So this shows that the process is able to produce as intricate designs as these that you can see here, some astoundingly beautiful and complicated patterns, and then different shades of course and different sizes of fabric can be printed. Let's move on to the first mechanized printing process for textiles, which is known as roller printing or copper roller printing. So roller printing was developed towards the end of the uh, 18th century, and the use of this machine reached its peak in the first quarter of the 20th century. That was the time when the only commercially significant process of textile printing was this one, roller printing. So this was a truly mass production process capable of printing at very high speeds. Interestingly, still today, after all the automation in the printing process, roller printing is still one of the highest productivity processes for textile printing. However, it's no longer used these days. So, very briefly, to understand the nature of this process, in this one, in this roller printing process, the design is printed using metallic rollers, and the outer surface of these rollers is made up of copper. So it looks something like this. Let's now have a look at this in more detail. As far as the procedure is concerned, the first thing that you need to notice is that just like in case of block printing, in case of roller printing also, one roller can be used to print only one color in the design. Perhaps most of you already know that any printed design can be broken down into its constituent colors. So that's the first step that we do in case of roller printing also. The design that needs to be printed is broken down into its constituent colors. So for instance, if you look at this image here, this image is made up of different colors and we are going to break it down into its component colors. As an example, I've shown 4 colors here, but this number can change. So for each color in the design, we have to prepare a copper roller, and the design areas for that particular color are engraved onto the surface of the copper roller for that color. So for instance, as you can see that in this case there are 4 colors. So we are going to prepare 4 separate copper rollers. On the first one, the design areas only for this yellow color will be engraved. On the second roller, the design areas for this magenta color will be engraved, and so on. So each color is printed by a separate roller, as you can see in the image here. Therefore, the number of copper rollers will always be equal to the number of colors in the design. In other words, the number of copper rollers will always be equal to the number of colors in which you have broken down a design. Let's now have a look at the printing cycle. So first I'm going to explain it in the form of this written text, these are steps, so that you can sort of memorize these. And then in the next slide, I will explain this procedure or the printing cycle graphically. So the first thing that is done is, of course, after preparing the copper rollers, they are mounted on the machine, and by some means, excess amount or very large amount of printing ink is applied onto the surface of each roller. And thus the grooves or the engravings that have been produced on the copper roller surface are filled with the ink. Now, one important thing that to note here is that in case of roller printing, the design areas are at depth and the non-design areas are at the surface. Then with the help of a metallic blade, excess amount of printing ink is scraped off from the surface, thus leaving the ink only in the grooves, that is the design areas. The fabric is then run in contact with this roller in which the grooves are filled with the printing ink, and therefore the ink that is filled in the recessed areas is transferred onto the surface of the fabric, that is printing is done. Now these steps will become more clear when we look at this in sort of an animation. So these are the copper rollers. Let's consider the surface of one of these rollers. So initially, the roller surface is smooth. That is, there are no grooves in it. And by some means, we produce grooves. So as I mentioned in the previous slide, the, the surface which is elevated is actually the non-design area, and the grooves are the design areas in this case. So this is actually reverse of block printing. If you recall block printing, then I mentioned that the design areas are raised while the recessed areas are the non-design areas. In this case, it's the opposite of that. The design areas are the recessed areas and the remaining part is the non-design area. So these grooves are produced by some method which we are going to discuss in the following slides. But for now, let's look at the printing cycle. So as mentioned in the previous slide, excess amount of ink is applied onto the fabric. Let's say we are printing green color. So the green colored printing ink will be applied in excess quantity on the surface of this roller. And then with the help of a blade, we scrape off excess printing ink from the surface, leaving the ink only in the grooves of this copper roller. In the next step, unprinted fabric is brought in contact with this copper roller, and as a result, the ink from these grooved areas is transferred onto the fabric. That is, printing is done. For roller printing, we use a proper machine, and there are different configurations that are possible. When I say machine configurations for roller printing, I'm referring to the arrangement of rollers in the printing zone of the machine. So the first type of roller printing machine is the one in which the copper rollers that are actually printing the fabric are arranged around the circumference of another large roller, which is called the pressure bowl. So in this image here, these this roller and this roller that you see are the copper rollers which are printing the fabric, and these are arranged around the circumference of this large drum that you see, which is known as the pressure bowl. So this is one possible configuration of the roller printing machine. Now a lot of different parts are labeled in it, so we are going to discuss those parts one by one. Okay, so we are going to start in the reverse order. So we will start with part that is labeled as H. So H is the color trough. That is the tray in which the printing ink is contained. You can see a roller labeled as G, which is placed inside this trough, and this is known as the furnishing roller. This is the roller which takes up ink from the color tray H and applies excess quantity of that ink onto the surface of the copper roller. So once again, I will highlight that this is the copper roller, and this roller G will take up excess ink from the color trough and apply this excess ink onto the surface of the copper roller. The next part that you need to notice is K over here, which is a lint blade. So any lint which is coming from the fabric onto the copper roller is removed with the help of this blade. Then there is another blade on the other side of the copper roller which is labeled as J. That's known as the doctor blade, and this is the blade which removes excess print paste from the surface of the copper roller. So if I repeat this cycle, then you can see that this roller G applies excess ink onto the surface of the copper roller over here, and then the blade J removes excess ink from the surface, while the blade K removes any lint which is transferred from the fabric onto the surface of the copper roller. So in this image here, the copper roller is actually, you can see it's made up of two parts which are labeled as L and F. So L is the central part of this copper roller and F is the outer part. Now, of course, this needs some explanation. By now, you already know that in roller printing, we use these copper rollers for printing. However, the roller is not entirely made up of copper for several reasons. The central part of the roller, which is labeled as L, is made up of iron, while the outer shell, the thick black outer line that you see, is made up of copper only. So it's only the outer shell or the outer surface of the roller which is made up of copper. The main reason for doing this is because if the roller is entirely made up of copper, then copper is relatively ductile and it will bend or flex under its own weight. Secondly, copper is also very expensive. Therefore, the central part of this large roller is made up of iron, while only the outer shell, which is actually doing the printing, is made up of copper. Now, somebody might be wondering that why the outer shell is not even made of iron, let's say. The reason is that etching on the copper surface can be done more intricately. So you can produce fine designs on copper surface in comparison to iron. Right, so some other parts as well, of course. So E over here is the fabric that you want to print. So you can see that the fabric is traveling in this direction, and when it passes in contact with the copper roller in this part of the machine, then the ink is transferred from the copper roller to this fabric. But then you can see some other layers as well, such as D. D is the back gray. It's just an extra fabric that is placed between E and C in order to avoid any staining of the blanket. So part C is actually known as a printing blanket. It's a conveyor belt which carries the unprinted fabric to the copper rollers and then takes it away or takes it out of this printing zone. So as you can see, the D is placed in between the fabric that you want to print and the conveyor or the printing blanket. And if the printing ink goes through the fabric, then it will not stain the blanket because the stain will be taken up by this back gray D over here. Then we have another part which is labeled as B. So B is this thick black layer that you see, and it's known as lapping. So lapping is just multiple layers of fabric that are wrapped onto the pressure bowl. This large drum that you see, which is labeled as A, is the pressure bowl. So because it's a cast iron drum, so its surface is not very smooth. Therefore, we cover it with this with multiple layers of a fabric. So it could be like 6 or 7 layers of fabric that are wrapped onto this pressure bowl. So the purpose of lapping is twofold. Firstly, it covers any unevenness on the surface of the pressure bowl. Secondly, it provides some resilience or some flexibility of the surface during printing. Now, this is a slightly tricky concept to understand. When we are actually printing on a fabric, we don't need a very rigid back support. We need a back support which is slightly resilient, because if the back support is very rigid, then the chances of smudging of the print will increase. So some resilience in the support behind the fabric that you are printing is actually good for printing, and that is achieved with the help of this lapping. And finally, A, which I've already mentioned, is a very large cast iron drum which provides the back support. So if you think intuitively, then you will realize straight away that when we are printing a fabric, we need to support that fabric against a surface, and only then we can print it. It's not like we can suspend the fabric in air and print it. Therefore, that back support in case of roller printing is provided by means of this pressure bowl. Now in this image that I've used here is from your book Textile Printing by W.C. Miles. So in this particular image, you can see only two copper rollers, one over here and the second over here. However, on industrial scale roller printing machines, you can have up to 8 copper rollers arranged around the circumference of the pressure bowl. So the point that I'm trying to make is that the scale of the machine is quite large. If you want to accommodate 8 printing units, that is this set of things, I'm going to call it a printing unit, which consists of tray, the furnishing roller, the copper roller, and the blades. If you want to arrange 8 such units around a drum, then you can imagine that the size of that drum will be very large. This is one important point to keep in mind, which we are going to rediscuss about when we discuss the limitations of roller printing process. The second type of machine configuration for roller printing is the one in which copper rollers are arranged in a line. So they are no longer around the circumference of a large drum. Therefore, the main advantage of this configuration is that you no longer need a very large pressure bowl. So the design of the machine is slightly improved in this case. Now, of course, this image on the left side is not very clear. This is from your book. You can refer to it and read all the parts. A description is provided. However, I have produced a simplified image of this machine here on the right hand side. So in this case, in this second type of roller printing machine, when the rollers are arranged in a line, the parts are this one. The first part is the pressure bowl, because still you need some back support, so the pressure bowl is there. However, you can see clearly that the pressure bowl for each copper roller is different. So this is the copper roller. So for this copper roller, the pressure bowl is here. For the second copper roller, there is a separate pressure bowl or a dedicated pressure bowl, and so on. So in this type of machine, if there are 8 copper rollers that you can use, then there will be 8 pressure bowls as well, a separate pressure bowl for each copper roller. The other parts remain the same. We need to have a furnishing roller. We of course have a color tray, and for the sake of clarity, I have not included the 2 blades that we discussed in the previous slide, but those are of course here as well. So everything remains the same. The principle remains the same. It's just a difference of the pressure bowl. In type 2, we use a separate pressure bowl for each copper roller. And in type 1, we use a single pressure bowl and all the copper rollers are arranged around its circumference. Okay, so we have been discussing that in case of roller printing, the design is engraved onto the surface of a copper roller. So we now need to discuss how this is actually done. So the first method to produce design on the surface of a copper roller is known as mill engraving. This is a purely mechanical method of producing design on the surface of copper roller. In this method, a metallic roller, which is known as the milling roller or the mill, is run in contact and under pressure with the copper roller. The design is actually raised on the surface of this milling roller. So this is how it looks like. In this example, the honeycomb pattern that you see is raised onto the surface, and this is the design that we want to print on the fabric. However, notice that in this image, what you see is the mill. It's not the copper roller. So this roller, when we run this roller in contact with the copper roller and under a lot of pressure, so that creates a negative impression of this design on the surface of the copper roller, and then it looks something like this. So as you can imagine that if we have these raised areas uh, and we have this hardened steel roller, and if we press it on the surface of a copper roller, then this honeycomb pattern is transferred, a negative image or a negative of this honeycomb pattern is transferred onto the surface of the copper roller. A negative image is perhaps clear to most of you, but I will explain. In this case, the honeycomb pattern is raised, but when it is run in contact with another surface, the honeycomb pattern is now recessed. So that's the negative of it. And this is what we want in roller printing. We want the design areas to be recessed or in the form of grooves on the surface. So now the ink will fill in these grooves. The ink will be filled in these grooves, and then fabric will be brought in contact with this surface and printing will be done. So of course, on larger scale, some very heavy equipment is used to produce design on the surface of copper roller using this technique. From this image here, you can also get an idea of the scale. I'm referring to this image. You can get a very good idea of the scale and the size of these rollers. So these are really very heavy rollers. The second method of producing design or engraving design on the copper rollers is known as is called chemical engraving, and it is also known as photochemical etching. In this method, the design areas are etched into the surface of the copper roller chemically, for example, by using an acid. Perhaps some of you are aware of etching of glass. So in a way, this process is very similar to that. If we compare the two methods, that is the mill engraving and the chemical engraving, then of course the two methods can be compared on the basis of fineness of the design can be that can be produced. So in case of chemical engraving, it is argued by some that very fine designs can be produced in comparison to mill engraving. Here are a couple of YouTube videos that you can refer to understand how etching of copper can be done. Now please note that these two videos for which I have included the link here, these are not directly related to roller printing. However, you will get an idea of chemical etching of copper with the help of these videos. So I'm now going to explain the chemical engraving process graphically. As you know that we start with a roller which has a smooth copper surface. There are no grooves or no raised areas in it. We then cover the surface of this roller with a protective coating. So the black lines that you see here are representing the protective coating that is applied on the surface of the copper roller. Now this protective coating is applied only on the non-design areas, while the design areas in which we want to produce the grooves are not covered with this protective coating. Then a chemical bath is prepared, and this copper roller with the protective coating on its surface is immersed into this bath. The chemical then starts to act on the copper, which is not covered with the protective coating. So that's the purpose of applying this protective coating, that the chemical in the bath cannot damage this protective coating while it keeps on reacting with copper, and the copper is dissolved away from these areas where protective coating was not applied. So after a certain time, as copper gets dissolved in these areas, of course, some grooves are produced. And then finally, after this process is complete, the copper roller is taken out from this bath from this chemical bath, and the protective layer is washed away, leaving the copper roller with the design areas in the form of grooves on its surface. Now, in this process of chemical engraving, the depth of the grooves is controlled by the composition of the bath and the time duration for which this copper roller is immersed in the bath. So as you can expect, if the bath composition is too strong, then in a given time it will etch away more copper. Similarly, if you leave the copper roller in the chemical bath for a longer time period, then more and more copper will be dissolved from the design areas and the depth of groove will increase. So this is one important parameter that we control in chemical engraving process, because the size of the grooves will actually have a direct effect on the printing process and the quality of print. I cannot give you a number that whether these grooves are 0.5 mm deep or 1 mm deep. That depends on the design, and that depends on the expertise and experience of the printer and the engraver. So in this slide, it's actually just a repetition of the process that you have seen in the previous slide graphically. So the non-design areas on the surface of the copper are covered with a protective layer. That's the layer which cannot be damaged by the chemical bath. The roller is then treated in an acidic bath. The acid etches away copper from the design areas because the design areas were not covered with a protective layer. And as I have discussed, the duration of the treatment in the acid bath and the composition of the bath will affect the depth of the grooves, which in turn will affect the quality of print. Let's now discuss some of the key advantages of the roller printing process. So the first advantage is that we can produce incredibly sharp designs using roller printing. So as we discussed in case of block printing, the sharpness or the fineness of the design totally depends on the skill of the person engraving the blocks. In this case, it's a mechanized process, or you are producing the design on the surface with the help of chemical etching techniques. Therefore, it's possible to produce incredibly intricate designs or sharp designs. Probably the most important advantage of roller printing is its very high production rate. So it is said that using roller printing method, we can print the fabric at speeds as high as up to 100 meters per minute. And although roller printing is no longer used these days, but I must mention that the present day printing techniques can usually not print at speeds as high as up to 100 meters per minute. They are restricted to normally 60 or maximum 70 meters per minute. So this is the fundamental advantage of roller printing, that its production rate is very high. And then of course, this is this process has a characteristic of excellent reproducibility. Reproducibility means that if you run a fabric, if you run a lot and print it once, and then after, let's say, a month, you run that order again, and you use the same copper rollers, then of course you are going to get the same design. Now let's compare it with with block printing. If you change the printer, if a month ago somebody else printed and today you have a different worker, then the pressure, the placement, and all the characteristics of the two printers can vary. And so it's hard in block printing to reproduce the design exactly. However, in case of roller printing, because we have these copper rollers on which the design is sort of permanent, and you can always set the printing pressure at the same level, therefore the designs are reproducible. Every time you print a design, you can get the same result, the same quality, the same sharpness, and the same appearance. And because this process has very high productivity or high production rate, it is suitable for very large quantities. So it's not economically feasible to print, let's say, few thousand meters of fabric using roller printing, because the cost of producing rollers is very high. So that cost is only justified if you have to print, let's say, 50,000 meters or more fabric of the same design. So overall, it will have lower cost of printing. However, this is a slightly tricky point, because the overall cost will be low in case of roller printing only if you have very large runs, very large production runs. Otherwise, if the order quantity is reduced, then the cost of roller printing will shoot up very sharply. And now some drawbacks or some limitations of this method. The first key point that you need to understand is that most of the limitations of roller printing are due to the weight of the rollers. You now know that the rollers that we use for printing have a solid iron mandrel, or central part is made up of iron, and a copper outer shell. So these are solid metallic rollers, and therefore these are very heavy. And most of the limitations originate from this fact. Let's look at this in more detail. So the first limitation is that limited fabric width can be printed. So usually less than 2 meter width of fabric can be printed. Why is that so? Again, that's due to the weight. If you want to print a wider width fabric, then of course you need a roller which has a larger length, right? If you want to print a 2.5 meter width fabric, then you need a roller which is at least 2.5 meter in length. So according to the width of the fabric that you are printing, the size of the roller will change. And if you increase the size too much, then of course that problem of weight that I mentioned will come in. So it will not be possible to handle those rollers easily, and that's why the width is limited. There is no other reason. It's only the weight of the roller which restricts the maximum width of the fabric that can be printed. Limited repeat size can be printed in case of roller printing. Repeat size is a term which I have not explained before, but probably you know already that in any printed design there is always a repeating unit, right? So that repeating unit is actually the circumference of the roller, and the circumference is again limited because if you increase the circumference to print a larger repeat, then of course as you increase the circumference of the roller, it will become heavier because the total volume of the roller will increase. So again, this limitation is also due to the weight of the roller. Then the third limitation is that limited number of colors can be printed. It's almost established that in roller printing you can print a maximum of 8 colors. This point is also in a way related to the same problem that I've mentioned at the start, that is the weight of the roller. Now, you can see that these rollers are very heavy and the fabric is passing between these rollers. So you can imagine that there is a lot of pressure that is exerted on the fabric. Now, if we have, let's say, 12 rollers, 12 copper rollers, then the first color which is printed will be pressed by these subsequent 11 copper rollers. And so the print will penetrate deeply into the fabric structure. The first color that you print will penetrate too much into the structure of the fabric. This is called crushing of print. So the limitation regarding the number of colors is due to this crushing problem, because the copper rollers, due to their weight, exert excessive pressure on the fabric during printing. So the printing ink or the colors are pressed more and more into the fabric structure. That's the crushing problem I was referring to. And then of course the handling of the machine, the handling of the rollers become also is also very difficult and dangerous as well. When this method was in use, there were accidents, and these the weight of these rollers is a problem when it comes to handling them. And the time that you need to spend on setting up the machine is also very lengthy in case of roller printing machine. That's again due to the weight of the rollers. It's not easy to remove them, and then it's not easy to put in new rollers. Therefore, it takes a lot of time when you are changing from one design to another. And despite the fact that this printing process has very high production rate, but the actual effective time of printing is less than 50% of the working time. So let's say if there is a 12-hour shift, for example, then on average 6 hours or more or less will be spent on setting up the machine. But once the machine is set up, it can print at very high speeds. So this setting up time is lengthy because of the handling issues related to these heavy copper rollers. And then lastly, the copper rollers are rather expensive to produce because they are all metallic. I've mentioned before that copper is also expensive, and then the engraving techniques, etc. All these things add up to the cost of these copper rollers, and that's why this method of roller printing is suitable only for very large production runs. You don't want to produce a copper roller at such a high cost and then print only few hundred meters of fabric from it. That's not going to give you any profit. And because you don't want to throw away or recycle the copper rollers, there is always a chance of repeat orders. So it's a very common practice in printing industry that the printing plate, that is the roller or the screen or the blocks, those are stored by the printer, because in case of a repeat order, they use those blocks or those rollers again. So in order to store these copper rollers, of course, very large space was required. Okay, we are heading towards the end of the lecture, so there's a question for you. Do you think you have ever seen roller printing in the industry? You all have done internships, I guess, and uh, perhaps you visited in different industries multiple times. So do you think you have seen roller printing anywhere? You have seen machines like this. So some of you might be relating this with roller printing. Let me tell you that this is actually not a roller printing machine. This is a type of screen printing machine known as the rotary screen printing machine. So I can assure you that um, you have not seen roller printing just because it's no longer used these days. Okay, let's summarize what we have learned today. So there are different methods of printing on textiles. These methods have evolved over time. In block printing, wooden or metallic blocks are used. The design is carved manually on these blocks, and it's more like a stamping process. The design areas are raised while the non-design areas are recessed in a block. It's no longer a commercially significant process. However, it has many technical advantages that we discussed, such as you can print any fabric quality, you can print any number of colors, etc. In roller printing, copper rollers are used and the design is engraved on the surface by mill engraving or chemical engraving methods. One of the points on which we can compare the two is that in case of copper roller printing, the design areas are recessed while the non-design areas are at the surface. Copper roller printing has very high production rate, perhaps the highest among all printing methods, but it has some serious handling issues. So in this lecture, we have covered only block printing and copper roller printing. In the next lecture, we are going to talk about different screen printing methods and an overview of a newly developed printing process known as inkjet printing. That's all for this lecture. Thank you for your attention.